Hello and good afternoon, ladies and gentlemen. My name is David Lynch and I'm accompanied by my friend Maddie. And today we are going to be talking about weight and balance. So, first thing we should discuss is the questions we have at hand. I'll list them off for you now. First of all, is what is weight? Why is calculating weight important? What is meant by balance in weight and balance? What is a moment? How do we calculate an aircraft centre of gravity? What is the danger of a centre of gravity that's too far forward? And what is the danger of a centre of gravity that is too far aft? Today, me and Maddie will go through these in depth and hopefully leave you with a substantial amount of information. Okay, so here we are. First, before we learn how to calculate weight, we're going to discuss the effects of excessive weight on an aircraft. First things first, higher takeoff speeds and runway length are required for takeoff, lower altitude and speed while cruising, an increase in fuel consumption, and that leads to less flight range, a higher stalling speed, and less maneuverability. Now that we've got that out of the way, I'll just give you a quick little visual intuition of it. So, bear with me. So, if we look at this plane here, if it weighs, let's say, 7 tons, so that's going to be 7,000 by G newtons. It's going to need an upward force of more than 7,000 to get off the ground. So it will put more strain on the plane since upward force is generated when it moves forward from the lift of the wings. And now that we got it out of the way, let's talk about calculating weight. There's 3 main things you need to know: gravitational acceleration, the weight, the formula for weight, and F equals ma in case you need to do any other kind of calculations. So F equals ma is basically the relationship between force, mass, and acceleration, and is used in most modern physics. W equals mg is essentially a calculation for weight, since weight is not a is a force, not to be confused with mass, which is a collection of everything I'm made of. And if we look at this simple little formula here, we see that we have gravity multiplied by the mass of the plane plus the mass of the payload or passengers plus the mass of the luggage, and that is plus the mass of the fuel. And it should be noted that fuel does change over time, so you'll need to consider that when flying. So now I will talk about moments. Moments are simple enough to understand. Essentially, a moment is the rotational force it's the rotational energy generated by a force acting on a lever which is pivoting on a fulcrum. And here we have a balanced system. It's a seesaw essentially. So as you can see here, Fd is equal to m, and F is equal to force. F is the force. D is the distance between the fulcrum and the object, and m is the moment itself. So if we want to calculate the forces, first we have to find the actual force going down. So in this case, it's 4g, and in this case, it's 5g. So now we have to figure out, are these two equal, and if this system is in balance. So it's very simple. So we'll do 4g by 50 gives us what is it, 5g by 40. So anyways, this is 4g newtons, which is roughly 9 times 4, so it's roughly 38. It's roughly 38 newtons, and this is roughly 49 newtons, but that's not a big deal. We can cancel them out. So as we see here, we essentially have 4 times 50 gives us 200, and then we let that equal. So 5g times 40, that gives us 200 as well. 200g as well, excuse me. So now the g's cancel out, and because they're equal, they cancel out too, so therefore the system is balanced. And speaking of balance, that's what I'm going to talk about next. So balance is essentially when all the moments on an object are equal, like we've just seen here. So for example, if I'm standing on one leg like this, all the forces acting on me are equal, and therefore I'm able to stand straight. But then we have to talk about center of gravity. My center of gravity right now is above my leg, but when I stand up straight, it's around here. And usually for humans, it will constantly change, but for planes, it's always the same when you've done your loading and all that. So Maddie's going to go through how to calculate center of gravity, but I thought I'd go through 2 things that are important. What happens when it's too far forward and when it's too far back. When it's too far forward, it means that you won't be able to flare for a landing as easily. And if it's too far back, you're losing a lot of stability and mobility and control over the plane in general. So now Maddie will take the calculations away.
Alright, so how do we actually find the centre of gravity of an airplane? To see if it lies within the specified centre of gravity range, we have a simple 5-step process. First, we need to list all of the items, their weights, and their arms. The arms of everything, as well as the weight of the empty plane, are supplied by the manufacturer. We need to know the weights of all of the other items, like the luggage and the passengers, and if necessary, we can find the weight of the fuel from its volume and its density. So once we have that, we need to find the moments of everything, and the moment, as we know, is just the weight multiplied by the arm. So we multiply the weight by the arm, and we get the moment for each of the items on the list. Then we define the total weight and the total moments. So we add up all of the weights here, which gives us 2,970, 2,970, and all of the moments, which in turn gives us 247,250. 7,250. Now once we have this, all we need to do to find the centre of gravity is divide the total moments by the total weight, and that will give us a figure, which in this case is 83.25. Now, if this lies within the centre of gravity range, which it does in this case, we're fine and the plane is balanced. If it wasn't, if it was too far aft or too far forwards, then we have a problem.
We have hopefully answered all your questions, but we'll go through them again just in case. So firstly, what is weight? Well, we know that weight is equal to mass times gravity, and it's the force that acts down on the Earth. And why is calculating weight important? Because if you have too much weight on a plane, it leads to a lot of bad effects, which can affect stability, takeoff speeds, and cruising altitude and speeds. And what is meant by balance in weight and balance? Balance is essentially when all the forces acting on something are equal, which is being demonstrated by me standing on one foot. What is a moment? A moment is the force acting on a lever that is pivoting on a fulcrum, which is essentially the turning force on a seesaw, for example. And I'll take you over to Maddie for the last three.
Now, how do we calculate the centre of gravity? Well, it's a simple 5-step process. We list all of the items, their weights and their arms. We find the moments, which is, like we said, multiplying the weight by the arm. Find the total weight and the total moment, and divide the moments by the weight to get the centre of gravity. And if it lies within the correct range, we're grand. If it's not, then we have a problem. If the centre of gravity is too far forward, the plane will find it very difficult to flare for a landing. While if it's too far aft, the plane will have reduced stability and just won't be able to right itself after, say, like turning.